we're just going to look at the number strand, and in particular the extra stuff for higher level. Since, we've completed the ordinary level stuff. So it's a kind of mismatch of things which are the extra stuff for higher level. And we're just going to use the low-hanging fruit approach. So today we're just going to get through some of the low-hanging fruit, so then that way at least we've gotten started. So the first thing we're going to look at is irrational numbers. So constructing the square root of 2 geometrically. So all you have to do is use Pythagoras. And so if you have the two lengths of a triangle being 1 and 1, then the hypotenuse is going to be the square root of 1 squared plus 1 squared, as in the sum of the square of the other two sides, which is equal to the square root of 2. So that's how you can construct root 2. If you want to do the square root of 3, so again start with 1, and then draw a right angular, like a perpendicular line, and then put a compass on the end of, like on this end, and set it at 2 units. So then, with the compass drawing a circle which is 2 units away, mark out where that hits, where that intersects that right-angled line. So that point is going to be 2 away from this point. The point being that this time the hypotenuse is of length 2 by construction, because this point and this point you used a compass which was set at being 2 units away. This length is 1, so then this length is going to be the square root of 3. And the reason for that is because from Pythagoras the hypotenuse is the square root of the sum of the squares of the other two. So that's 1 squared plus the square root of 3 squared, which is the square root of 1 plus 3, the square root of 4, so it's 2. So that's how you construct the square root of 3. Finally, we want to show that the square root of 2 is irrational. So show, in fact, stronger than that, prove that irrational. Well, then that just means that prove that you can't write it, or prove that it's irrational, so that that means it isn't rational. So we prove that we can't write the square root of 2 as a fraction. So how does that work? Well, if the square root of 2 could be written, so if the square root of 2 was equal to p over q, where p and q have no common factors, since we cancel them. If there were common factors, we want to reduce it down to a fraction which has no common factors. So if root 2 is p over q, then we can square both sides. So 2 is equal to p squared over q squared. So we can write that as p squared is equal to 2q squared. So that implies that p squared is even, because it's equal to 2q squared. So then that means that p is even, because that's the only way you can get p squared is even. So then that means that p squared is divisible by 4. Since if p is even, that means it's divisible by 2. That means that p squared is divisible by 4. So then, nearly done. That means that q squared is even, because if p squared is divisible by 4, so the left hand side is divisible by 4, we divide both sides by 2 and we end up with q squared is even. But that contradicts fact that p and q have no common factors. Which we said at the start, because if q squared is even, then q is even, and so both p and q are even, so both would have a common factor of 2. So therefore square root of 2 cannot be written in the form p over q, so the square root of 2 is not rational. So square root of 2 is not rational, it's irrational.